So now we're looking at 10a.5, calculating permutations. So now that we've learned about factorials, the exclamation mark symbol, we can start assessing permutations in a more rigorous way. You may remember from 10a.1, we were just going and using the multiplication rule. 7 times by 6 is 42, or 6 down to 3 is 2520. To work out the number of arrangements of people who could be winner and runner-up, or people who could line up in certain ways. Even our arrangement of our word step can be figured out using this manner as well. We're going to have a more rigorous approach to this now, which is using our permutation rule. The permutation rule is more formal and it uses the exclamation mark symbol, the factorial symbol. Is it more useful? Well, sometimes it is, sometimes it isn't. Sometimes tackling it like we just did is a good way of going about it, but to know this way will help us assess trickier questions and also learn the notation of counting techniques. Now in this case, we're doing 10a.5 and we have a bit to go through. So, first part, what is a permutation? Well, permutation is the number of possible arrangements, which is called the permutation itself, of n objects of people that are arranged of rows of objects of people of r length. So, the notation for this, I'll just highlight it here, is NPR. So, we've got an example here, Steve, Gerald, Tim and Kev. They can be seated next to each other in SGTK, so Steve, Gerald, Tim and Kev, or Steve, then Gerald, then Kev and Tim if you want to picture it, or you can go Gerald and Tim and Kev and Steve. That's a bit of a tedious way to do it, okay? So we can use counting techniques, in this case permutations, to express this. So using our notation, you may note here that we've written this as 4p3. Well, where do those numbers come from? Well, we know that n, in this case, is the number of people that are chosen out of. So we know that there's 4 people. So I'm going to highlight this in green. There's 4 people, and therefore n is equal to 4. We put the n value here for our notation. Now in blue, I'm going to highlight our r. This is the number, the arrangement length. In this case, the arrangement length is referring to how many seats are being put out. So we can see the number of seats being put out is 3. So we can say in this case, r is equal to 3, which is expressed here. So we always have the n as the top number in the top left and the r as the bottom right number. Now we do have a formula for this. So you may note from before, n factorial. N factorial means all the integers timesing together. And that number goes there, and it also goes down here. You can see up here, the 4 goes there, and the 4 also goes there. Now the other number we have was 3. So we have the 3 here, matching our formula, and the 3 goes here. If we evaluate this, we can see that it becomes 4 factorial on 4 take 3. So we're using our BIMDAS as we normally would. 4 take 3 is 1, and then we don't need the brackets anymore, so it's just 1 factorial. Now we know this is the same as saying 4 times 3 times 2, which is 12 ways of this occurring. So Steve, Gerald, Tim and Kev can be arranged in 12 different ways. So our first step is we want to evaluate this by hand and then confirm our answers using the class pad. So we're just going to practice using our formula for the permutation. So our permutation equation works like this. 5p3 is equal to, so we know here that top number, n, is equal to 5, and that number there means r is equal to 3. So let's sub that into our permutation equation. So instead of writing n factorial, I'm going to write 5 factorial divided by, and then 5 minus 3 factorial. We evaluate this, 5 factorial over 5 take 3 is 2 factorial. We know how to divide these now, so it's going to be 5 times by 4 times by 3 times by 2 factorial over 2 factorial. They cancel out, and we're left with 5 times 4 times 3, which is 60. To confirm with using our calculator, we can use our permutation rule now. We can go 5, shift 8, and then we go 3. Apologies, I was meant to say this. 5, comma. So the first value here represents the n, and the second value here represents the r. And we can see here we got 60. Pause the video and have a go at the your turn now. The your turn will continue now. So we have 10 factorial over 10 take 7 factorial, which is equal to 10 factorial over 3 factorial, and this one here is going to be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 factorial over 3 factorial. I can't blame you if you just assess this in your class pad right away, but if we multiply them all together, and I'm just going to go shift 8 and then type in 10, 7 while this is loading. Still going there. I've got an answer of 604,800. I'll write that underneath. 604,800 possible permutations of that situation. In this case, the 10 represents the number of people chosen out of, and 7, you have 7 seats in a row if you wish. We'll move on to the next set of worked examples in the next video.